Hello? Are y'all all in the classroom together? Maggie, are you at school? Oh, yeah. So where is Olivia then? Oh, you guys are so cute. I'm going to try to be there next week, okay? That's my goal. Oh, that's Kari.
That's glasses.
Am I right, Kari? I don't know who that is with a mask. I can't tell. Who's that one?
That's Anna.
Where's Olivia? Where'd she go?
One for 145.
Is nobody going to tell me where Olivia is? Polly, I know that you don't know where Olivia is. You're not there. Henry, you're muted if you're talking to me. Oh, what are we going to do today, guys? What do y'all want to learn? How about quadratic equations? Does that sound good? All right, so can somebody talk to me? Is Olivia coming? Can we use our voices and talk?
He's being difficult.
Henry, your mute is off, but you're not talking. Y'all are killing me. Yes, Polly, I know you're not there. I have nothing on the way. I guess we still have a minute. I have the Monday, like, I just am tired day. Did one of you guys hit record or did I? I mean, I didn't, but it's recording. Did somebody start the recording? Maggie gonna talk to me?
Maggie, talk to her.
I don't think we can start the recording. I think only you can.
Are you talking, Maggie?
I think only you can start the recording.
That's not good, Polly. Where is, oh my gosh. Okay, I have my volume off, so that's a problem. Now, did anybody say anything about where Olivia is? Apparently my volume was off.
She's having problems.
Yeah. Oh, getting logged in? Or is she having mental problems? I can't tell. Like, is her head down on her desk like she's losing her mind?
Is it mental or are you actually having problems? That's what she wants to know.
Like, she looked like her head was down on her desk. Because she could look on with one of you guys, right? I guess you can't sit that close, though.
5 more seconds. She says 5 more seconds.
Okay. Thank you, Maggie. All right. Henry sent me a picture of that quiz, but, and you guys can send me a picture or I will be there next week. You can just bring them to me next week, okay? I'm hoping to be there next week. As long as I don't have meetings or anything, I should be there. I had a bad headache all weekend, and so I was worried that I could have the Rona, but I don't think I did. But we had people from out of town here last weekend and stuff, so who knows. But I'm fine now. Took some sinus medicine, and I'm good. But anyway, so I just didn't want to risk it. All right, so did anybody have, and I know Olivia's coming, I'm just going to start a little bit anyway. Did anybody have questions about the homework? Would anybody like to ask any questions about the homework? You can say it or you can put it in the chat.
I have that and I talked to you.
Talk loud.
Hold on.
Hold on. It also might be my speakers. So did you have a question?
Can you hear me now?
Yes.
No, it's frick.
Now you're muted again. Is it muting it on its own?
No, I'm doing it. Oh, there we go. Okay, we're good.
Yeah, I had to do it on my
Okay, so Olivia's here now. Hi, Olivia. When she said you were having problems, she showed the room and it looked like your head was down. That's why I asked if you were having mental problems. Like, I didn't know if she meant like you were having a meltdown. I couldn't tell. It's okay if you were. I'm not, no judgment. I just wasn't sure what kind of problems you were having. Okay, so Henry, did you have homework questions?
I had that first one I was talking to you about, the one I texted you.
Yes. Did you understand when I responded to you what I told you when I told you how to do it? Did it make sense?
Yes, I did. I understood it.
Okay. So I'm hoping to be there next week, but we're gonna move on. I'm getting better at writing on this whiteboard thing. We are moving on to this. If you want to write this in your notes, we are doing 5.5 first. Quadratic equations. So last week we reviewed factoring and we reviewed radicals. That was to prepare us to do quadratic equations. I still don't write words very well on here. Ooh, there we go. It's easier to do cursive. Okay, so quadratic, first of all, when I say quadratic, I mean, let's write this actually. I mean equations where there is, the highest exponent is 2. That's what I mean when I say quadratic, okay? I mentioned last week that these are, if we were to graph these, they would be parabolas. We are not going to graph these right now. We may come back to graphing these, but we're not going to right now. But I am going to just draw this graph here so I can show you something in a minute. So if we were to graph these, we would make them, they would be parabolas, okay? And so when we're looking for solutions, so write this down before we get to these answers, solutions to these kinds of equations, first of all, there will be 2 solutions, okay? And we can call them solutions. We can also call them zeros. Hold on. So we can also call them zeros. The reason we call them zeros is because we're basically looking for where it crosses the x-axis, okay? So like here and here. So essentially we're looking for what is x. Oh my goodness, you know what, I could type this. Why don't I type this? This part, because I want you to put this in your notes. Let me see. So we're looking for what is x when y is 0. That's kind of the goal here, is what is x when y is 0. And if it's a parabola, it's going to cross the x-axis twice, if it crosses the x-axis. We'll get to ones later that don't. So we're looking for what is x when y is 0, and you will always have 2 answers, okay? We're going to get these answers 2 ways, at least for today. Well, yeah, today. We're going to solve by factoring, and we're going to solve by finding square roots, okay? Give me a thumbs up when I can clear this page. And Polly, just say clear it when you're ready, or if you're not ready. Got a thumbs up. Olivia's talking to somebody. I don't know who. Can I clear? Maggie, can I clear? Not yet? Yes? All right, Polly, I think I'm good to clear, I hope. Okay, so let's do an example. First, we're gonna, oops. No, I want that. First, we're gonna solve by factoring. Okay, and I'll show you what this looks like. Hopefully you guys did well on all of the factoring. You guys didn't have any questions, so I'm assuming that means that you know how to factor. So let's look if we have a problem like this. 2x squared minus 11x equals negative 15. Okay, step 1 is to get it equal to 0. Okay, if it's not already equal to 0, that's step 1. I should have typed that. Get it equal to 0. Okay, so over here, my first step is going to be to add 15 to both sides. Boom. Gone on that side. All right, and then make sure you're writing it in what we call descending order of exponents. That means that you have the squared, then you have the x on its own, then you have the constant. You got to have it in order. Okay? And then once you have it like this, we're going to factor. So this equals 0 is just kind of over here for a minute. You don't need to worry about it too much yet. Let's factor. Remember, we multiply those two. Okay, and then we list factors of 30. We could do 6 and 5, 3 and 10, and so on. And I'm looking for factors that when added or subtracted will make a negative 11. If both of these are negative, then this will be a negative 11, okay? So I'm going to come over here, and I'm going to change negative 11x to negative 6x minus 5x plus 15. Okay, and then go ahead and finish out that factoring. So these first two, we can take out a 2x, and I get x minus 3. Now that's kind of our clue for what's going to happen in this next one. Remember, if this is minus, we take out a negative. So I'm going to take out a negative 5. And as I take out a negative, that changes the sign of that. Okay, it was a plus 15. Now it's a minus 15. If you did it right, these two will match, and we did. So I'm going to bring down the x minus 3. I'm going to cross them out. If I'm going too fast, just ask me to slow down. I probably need more coffee because I'm actually really dragging today. So I'm not even in my hyper caffeinated state that I usually am in at this point of the day. I probably will need to get some caffeine though soon. All right, I'm going to erase over there. Okay, so this is what we have now. I'm going to rewrite it up here. So I have x minus 3. I'm just rewriting it because I ran out of space. Times 2x minus 5 equals 0. So once it is factored, okay, then we're ready to solve. And this is how I explain this. You guys might have done it differently at some point. These are my two factors. I draw a little squiggly line, and I give each of them their own 0. And then I'm going to solve those. So first, I make that x minus 3 equals 0. Over here, I make it 2x minus 5 equals 0. Okay? Now you solve each of those. You guys know how to solve equations. We're going to add 3, so we get x equals 3. Over here, I'm going to add 5 first, so I get 2x equals 5. Then I'm going to divide by 2, so I get x equals 5 divided by 2. And those are my two answers. okay? 3 and 5/2. And you can leave it 5/2, okay? So that's solving a quadratic equation by factoring. Whenever you start your problem with a trinomial, with an x squared, an x, and a constant, you're gonna solve it by factoring. Let's do another one. Can I clear? All right, let's do another example. Let me find a good one. Hold on. What if we do, I'm gonna make it up. This is gonna be dangerous. Let's do 3x squared minus 27x equals 0. Okay, so this one has an x squared and an x. There isn't a constant here, but that's okay. We can still solve this, okay? So we're not going to be factoring into the two binomials, but we do have a common factor here. They both have a 3 and they both have an x. So I'm going to factor that out. You always factor out a GCF at the beginning if you can. Okay, so some of these factorings are going to be factoring a trinomial into two binomials, and sometimes you're going to do this. So this is as factored as it's going to get. So my squiggly line goes between those, okay, and each gets their own 0. And then you solve each of those. Now, over here, I have 3x equals 0. I divide both sides by 3. X is just going to still be 0. Over here, I'm just going to add 9. So I get 0 and 9. Okay? So most of the time, you're going to see those trinomials into binomials, but you might have this too. Okay? All right, how about we do a square root 1? I'm just going to draw a line right here in case anybody still needs to see that. So let's do one that has a square root. Let's do this. 5x squared equals 80. Now, one of the biggest problems when we're doing something like this that students ask is, how do I know which one to use? So each time I'm trying to give you examples like this one. You see how there's an x squared, but there's not an x, okay? So if you only have an x squared, you're gonna solve by square roots. So that's what we're gonna do is to get this by itself, we are going to, so I'm gonna get the x squared by itself, okay? So I'm going to divide by 5, divide by 5. Anybody know what 80 divided by 5 is?
16, I'm pretty sure.
Yep, 16. Okay, now, so we get x squared equals 16. Now to solve this, we have it almost by itself. In order to make x squared x, we can take the square root. This is where those radicals come into play. We can take the square root of both sides. The square root of x squared is just x. And the only thing you need to be careful of here is that when we take the square root, we actually have to say that the answer is plus or minus whatever that square root is. In this case, it's simple, it's 4. And that is because if we square positive 4, we get 16. If we square negative 4, we get 16. Okay, so that's why we have to take that into account. So when you take the square root of both sides, stick that plus or minus in front of it. Okay? We'll do another one like that. I love this whiteboard. Do you know remember how bad it was last year when I was trying to teach who was in my class last year? Henry was, and Polly was, when I was trying to teach with a, like, holding a whiteboard up. It was not fun. Not fun at all. All right. Okay, so let's do another one. Let me find a good one. Let's do, I want to do a messy one. Let's do this one. 5x squared minus 40 equals 0. So there are actually a couple of ways to do this, but for now we're going to do it. We're going to stick to this one method, okay? Notice we have an x squared, but we don't have an x. That's your clue. That's your ding, 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 your clue that you are going to get the x squared alone on one side and everything else, or the constant, on the other side. So first I add 40. I get 5x squared equals 40. My goal is to get that x squared alone, okay? So then divide by 5. So now I have x squared equals 8. Okay, so those were just steps. Remember that it's pretty sad news how Aunt Sally must die. We take care of what's added and subtracted, then multiplying and dividing. Now we have the squared alone. Take the square root, take the square root. This is where what we did for homework with simplifying radicals comes into play. First of all, I put the plus or minus, and then if you want to work it out over to the side, you can. So 8 breaks down into 4 times 2. I probably should have done this a different color. The 4 breaks down into 2 times 2. So we have one set of twins and one left over 2, right? So a 2 comes out, a 2 dies, and a 2 stays in. So our answer here is plus or minus 2 radical 2. Okay? Okay. Any questions about that you can think of? You guys got it? Can I clear? Maggie, are you still writing? Okay. All right, so that is the solving quadratic equations. The next lesson I want to do is one of my favorites because I get to tell you guys about imaginary numbers. Did you guys know that there were imaginary numbers in this world? This is called complex numbers. Is that you in the chat box, Polly? I have my thing is like hiding. Oh, wait, there it is. Ah, I don't know why, but like the bar at the top has gone away. Polly knows that there are imaginary numbers. Okay, so when we get to, so remember I told you, let me show you this. So remember I told you that solving quadratic equations is when like the 2 answers that we get are where it crosses the x-axis. Well, what if my parabola is like up here? It's never going to cross the x-axis, right? Oh, thank you, Polly. Polly's giving me Zoom assistance. Oh, you know what? I have another screen now for my, but you guys aren't attached to it. I just tried to move that. Anyway, doesn't matter. So this is how the solutions look when it's a complex number. Basically, when there's no real solutions is what we call it, okay? Here's what you need to know. The square root of -1 is I. That is that's the imaginary number. It's the square root of -1. The imaginary number, I. Okay? You need to know this. I'm going to show you a couple of other things that you have to know to understand all this. So the square root of -1 is I. I squared, if I take I times I I just get -1. You see how that makes sense? If I square this, okay, I have twins, I have two -1s, they come out as -1. Okay? I don't think this gets into it yet too much, but there's kind of a whole system here, like a whole little I world. I to the third would actually be a negative I. Can you guys tell why? If I take I, multiply it by I squared, okay, whenever you see an I squared, you automatically replace it with a 1. So then we have I times -1, which is going to be -I. Yes, Polly, all imaginary numbers are square roots of negatives. That's how we get them. And then the last little one here is if we do I to the fourth, that's I squared times I squared, which would be a +1. And then you kind of can use, again, I don't know that there's anything for these in what we're going to do for homework, but I know that there are situations where like and this could come up on like ACT or something, where like you're told to tell what I to the 31 is or something, okay? If you're asked to find I to the 31, it's going to be one of, sorry, which are things that shouldn't exist, but kind of, yes, exactly, Polly. So if you're finding I to the 31, okay, there's 4 choices for your answer. I, -1, -I, or 1, okay? And again, I don't think I have any problems like this planned for your homework, but this is, you may see this at some point. So we could take I to the 31 and we could do this. Like I could write it as like this, I to the 4th times I to the 4th, and I could do this 7 times because 7 times 4 is 28, okay, you follow me? And all of those are 1s. So if I did this 7 times, remember that when you're multiplying powers, you add the exponents. So let me get 7 4s up there. So that's I to the 28th. And then I could just throw in another I to the 3rd. So all of those I's are all 1 each, so they're just 1. But then I to the 3rd is actually -1. So I to the 31st is -1 because it's 1 times -1. If that is super confusing to you, don't worry about it. I don't think it's going to be a big deal, okay? Polly is asking, is there something like this for dividing by 0? There isn't. Dividing by 0 is just illegal in math. You just can't do it. All right. Moving on. Can I clear? Because now I'm going to show you, we're going to do stuff with complex numbers, okay? Again, you are probably not going to actually do a whole lot with the big I things, but complex numbers are always written in this form. A plus BI. Okay, that's how complex numbers are written. A plus BI. The A is the real part. The BI is the imaginary part. Okay. And we're going to do quite a few different things with complex numbers. We're going to add them, we're going to subtract them, we're going to multiply them, we're going to divide them. First, we're going to make them, okay? So like, for example, if I asked you to rewrite with imaginary numbers the square root of -8. So previously in your math life, if you had square root of -8, you would say that's no solution, right? But now we're going to have imaginary numbers. Now you have to do the work. So we actually just in our last problem, we did this, right? So what you can do first when you're solving one of these is the first thing that happens is an I comes out of the radical. That takes care of the negative. Then you just proceed as normal. Okay, we break this down. We've got twins, a 2 comes out, a 2 dies. That's 2I, radical 2. Okay, before I start the adding, subtracting, multiplying, dividing, we're about to be booted out. So let's exit. If you need to run to the bathroom, do so, whatever, and then pop back in on that 115 link. They might be the same link. I don't know, but pop back in on that 115 link, okay? So I'll see you guys in a minute. Oh, what did you say in this chat? All right. All right, come back in a minute.